Okay. This is the third and final Windows talk. It's called Windows and AD Defense, How to Win. I'm really, really confident that if you take the things that I talked to you about in this talk and you apply it and you practice it, your Windows machines will be impenetrable. The red teamers at CCDC are not that good at Windows. I've talked to them. I've worked with them. And I promise you, they're not doing anything too crazy, okay? So this talk is going to be about how to detect things, how to write your own detections, and a little bit about how to prevent attacks that I talked about yesterday. Now, I'm going to cover the basics of Windows logging first, like absolute basics. If you're unfamiliar, I'll show you how to come up with your own detections, and then I'm going to talk about like just kind of some attacks and how to defend them. I made this talk very, very quickly, so it's going to be pretty short. It's going to be pretty unstructured, and it's kind of going to be me rambling a little bit. But, you know, ask questions, give me your ideas. I hope it's useful. So here's my methodology for Windows, right? If possible, you want to get on a network, and you want to patch everything. Right? You want to make sure that everything's hardened. You're not allowed to have weak passwords. You're not allowed to run exploits. You're not allowed to exploit vulnerabilities or put command and control software on there. But for CCDC, that's not going to happen, right? It's not possible. You might be able to do that for Cyberforce. You probably can. It's like a week, right? You might even be able to do it for NCIE, even though that's an entirely Linux competition. But when you get on a network and people are immediately attacking you, or when you get on a network and it's already infected, like CCDC, you want to have a backup. So here's the backup, right? Let's say that you know that some Windows machines have an exploit, a CVE from 2020 that was unpatched. Instead of going on and patching everything, you can write detections. So that way, hey, you're busy like finding all the attackers in your system. If an attacker exploits, like zero logon, anyone remember zero logon from yesterday? Vaguely, right? If someone exploits that, which requires no credentials, you can detect it. Who remembers what the big issue with zero logon is? Like, what does an attacker do?
Wasn't like they have no username and no password, but there's like
That's null authentication in SMB, yeah? You're thinking of SMB authentication. Zero logon is a vulnerability in which in the
RPC, right?
Yeah, it was in the net logon protocol. It was a crypto vulnerability that allowed you to reset the domain controller machine account hash. So you can write a detection. If the domain controller's machine account hash gets reset, you detect and you say someone just exploited zero logon, and now you as a defender will report that because that's going to get you points at CCDC, and you also go and patch it. Right? And it's like better late than never. That makes sense? Okay. So let's cover some absolute basics. In Windows, before you do any logging, you first have to enable logging, right? Now you can do this manually. Now there's a really important concept in Windows called GPOs, Group Policy Objects, and these are things that let you define the policy of objects in Windows. So you can set things up. Well, I think I have some stuff here, yeah. So there's local group policy for local machines, right? And there's also a domain group policy that if you set it up on the domain controller, it'll distribute it to all the machines on the domain if it's set up correctly. In CCDC, that might not be the case. So typically, I would recommend that you set up group policy on all the machines. But in a real network, just put it on the domain, and it'll spread it out to all the machines. It'll set stuff. Here's some examples. You can enable logging for when someone fails to log in, for when a TGT or an ST are requested, for when a file is accessed, for when a certificate for ADCS is requested. There's success and failure audits, right? You succeeded to log in, you failed to log in. You could also change the password policy. Minimum password length is 12 characters, and there's so much more. And these are great ways to just really quickly harden your system and log things. That makes sense? Okay. Now, Windows by default, especially, now it's a little bit different for Windows Server 2025 and Windows 11. Those are pretty secure nowadays, but older Windows, pretty much all security features are disabled by default. So what you want to do is you want to learn about the security features, what attackers might do, and you want to learn about the security features and like which ones will prevent attacks. Yes?
Why are they disabled by default?
Because it's easier.
For like the user to interact with the system?
Yes.
Okay.
Right? So one of them I talked about is SMB signing. Right? If SMB signing is enabled, SMB is slower. And Microsoft doesn't want your SMB to be slow. So, what they did is for default, by default on workstations, SMB signing is disabled, right? And LLM&R, you remember that thing we talked about yesterday? That's enabled by default, et cetera, okay? Now, when you're logging, Windows has this thing called Event Viewer, right? I enable logs, and every single event, which is like, you can think of it as a log, is going to have an ID. So let's see. Do I have the ID here? Maybe I don't. For a new process in Windows, the event ID is 4688. I just have that memorized, as do a lot of defenders, because it's really important. When someone executes something, you want to know what they're executing. So here you can see what the process ID is, what they executed, calc.exe. You can see the security ID, the account name, the account domain, etc. And this is really useful for logging. Right? On a normal machine, it makes sense for low privilege users to be executing stuff, but if the admin user is executing things, especially if it's something malicious, that's kind of rough, right? Now, Event Viewer is notoriously really, really annoying to use. It's really ugly, it's really slow, the logs are hard to read. So as a result, someone, Mark Rasinovich, who made the sysinternal suite, made this tool called Sysmon. It was actually Mark Rasinovich and one other guy, and I always feel so bad that I forget the other guy's name. But Sysmon is something that will enrich your logs and give you more information. So here's the same log, process create, but you can see that we also see the parent image, the parent process ID, command line current directory. It's a lot easier to read and it's a lot more useful. Do people see why? Right? It's really good to see the parent process because like if your web server spawned a Python process which spawned a shell, that's suspicious, right? So you can write Sysmon rules for this. Now, we use Wazuh or Wazuh for a lot of competitions. Here's a rule that I wrote for Cyberforce last year in which I said, let me look for the process or event ID 4768, which is when a TGT is being requested. Now TGTs can be requested legitimately, but they can also be requested with an AS rep roasting attack. So what I did is I said, hey, if I get a 4768 and the username is one of these users, which in this case I knew which users were vulnerable, right? If you don't know which users are vulnerable, then you just kind of, you look for all the TGTs being requested. But I said, hey, I see a TGT being requested for this user. This could indicate AS rep roasting, right? So I know what the attackers are doing, and as a result, I can write logs to match that. That make sense? Questions so far? Okay. Here's some other rules I wrote, right? For 4688 again. Where does it say that? Oh, does it not say that? I think my base rule 130200 was 4688. But basically what I'm checking is I'm looking for every single malicious binary that I know of that runs on Windows, like certify exe, God Potato. You remember me mentioning God Potato yesterday? And if I see that those are being executed, I say malicious binary has been executed. Now, most attackers are probably not going to be so dumb that they forget to change the name, right? If you see evil.exe being run, it's probably bad. If you see redteam.exe being run, it's probably bad. But, it's a good rule to have. Sometimes attackers forget the obvious. Sometimes in competitions, attackers are nice to you because competitions are meant for learning. So, it's good stuff. Here's some rules you can look at if you want to see more. Now that was like all local Windows stuff, right? You see it on the actual machine. This is a tool that I love for seeing Active Directory attacks. It's this thing called LDAP Monitor, written by this guy Podolerius, and it's something that will monitor all the changes in LDAP. So remember, LDAP records and stores all the information about all the objects and the users and the groups, right? So let's say I do an exploit. I have a Bloodhound attack path. And Bloodhound tells me, in order to become domain admin, you have to write to this object and add yourself to this group. LDAP Monitor is going to show me exactly which attributes were changed, and it's going to show me this person got added to this group. If I change my password, it'll show up here. If I give myself more privileges, it'll show up here. So this is something that's really, really fantastic for identifying, just on your own, identifying things, and you can use this to write rules. One other thing that I used this to discover, I wasn't the first to discover it, but there's a thing in Windows called a shadow credential technique where you can add multiple passwords on a Windows account. So who wants to guess how many passwords one Windows account can have? Andre?
24.
24. It's actually, well, it's higher. Anyone else want to guess? Yeah?
50.
It's 257. And that's because you can have up to 256 private keys by default associated with your account. An MS key credential link is something that will be modified anytime a private key is added to an account. And this is something that does not happen very often, especially when your domain is not connected to Azure. So I know that this is rare, and I know it's suspicious. So if I see that a private key is getting added to an account, I probably know that it has been exploited, right? And this is something that I found out by looking at LDAP Monitor. Now, if you want to find your own, vulnerabilities and logs, and you want to look for your own stuff, these are two tools that I really, really highly recommend. The one on the left is something called Atomic Red Team, which is something that will emulate a ton of attacks by red teamers. And the one on the right is called BlueSpawn. This is something that was actually written by some UVA students specifically for CCDC. And that's a YouTube video of a DEF CON talk that they gave about it. But they did a ton of cool stuff where they try to write detection rules for every single, or as many as possible, TTPs, which are tactics, techniques, and procedures that actual attackers do, right? And I really recommend going on your home lab and trying to write rules and being like, let me execute the Kerberosting TTP and see if BlueSpawn detects it. If BlueSpawn doesn't detect it, then you can go in your event viewer and you can go in Sysmon and you can see what logs happened. You can write a rule and then you refine them. Make sure there's as few possible false positives and false negatives. Make sense? Okay. Here's an example of me running an atomic test. Here's an example of BlueSpawn saying, I detected, what does it say? T1547, boot or logon auto start execution. Yes?
When you write a new rule, how do you test for false positives or false negatives?
So a false negative is pretty easy. I do the attack, it doesn't show up, rough. A false positive is much harder, right? I just have to try to, let's say I'm looking for Kerberosting, then I want to look for STs that are being requested. So let me legitimately request an ST and make sure that doesn't alert. And then let me try to do Kerberosting, and we'll see if that does alert, right? Now, sometimes you can't really refine it, but generally we prefer to have too much logging than too little, right? Because we can look through all the logs and the alerts manually and we can find the issues. That make sense?
Yeah.
All right, let's talk about threat hunting. You've already learned about this. There's something called the sysinternal suite that includes some tools, one of which is called auto runs, which will let you look for anything that will automatically start up or automatically run at certain periods of time. It's not going to find everything, but it also has some cool features like letting you automatically upload to VirusTotal and find vulnerabilities. It'll let you look for things that are digitally signed. So if it's signed by Microsoft, it's probably fine. If it's self-signed or not signed, then you know that it's a little bit suspicious, right? Now on Linux, pretty much nothing is signed. But on Windows, almost everything is signed, like everything, right? So if you find something that's not signed, you should look at it. Here's an example from the first lab that we did. And this is how I found the SVC host exe. You see on the right, it says 66 out of 77 vendors said it was suspicious. So I think that's a good enough metric, right? Yeah?
So for UP lockdown, it says we're not allowed to upload things to VirusTotal, but can we still use auto runs?
You can use auto runs, but you cannot use the VirusTotal feature.
Okay, so we have to turn off the VirusTotal feature. How do we do that?
It's turned off by default.
Oh, okay.
Yeah.
So you would have to enable it. So
would have to
is that
enable
the
it.
case for all competitions? Like you can't upload things?
CCDC is the same. Cyberforce is not,
Okay.
unless they change the rules.
I didn't see anything about that.
So Cyberforce.
Last I checked, Cyberforce did not change the rules.
Okay, so Cyberforce you can upload
Okay.
stuff.
Okay.
Yeah.
Cool.
Proc Explorer is something that does Process Explorer is the same thing, except it'll show currently running processes. It will also look for things that are digitally signed, also let you upload things to VirusTotal. And it'll show you like network connections and things, right? There's also a bunch of colors that all the processes have, and I don't really understand them, but if you learn them, they're useful. All right, this is my favorite part of the talk, detection. I'll be honest, this is comprised of just a lot of random things that I picked up over the last couple of years, and some of which I don't really have evidence for, at least not off the back of my hand. So you'll just have to take my word for it. If you want, you can ask me later where I found out these things or how I found out, but unfortunately I did not have the time to like make it super in-depth, so just forgive me for my craziness. Okay, detection. You remember first step we want to do in an attack, SMB, null, and anonymous authentication. These are things that I think should be disabled, but you know what, in CCDC you might not have time to do that. So what do? You just look for null and anonymous authentication. That's something that should not be happening in a real environment, especially with very, very few users. So if you see that, you can sometimes say, hey, that's the IP address that's logging in, that's kind of suspicious, and you just disable it. This is a really great blog post about how to do that. You should take a look. Now, who remembers this screenshot from my talk yesterday? NetExec can enumerate SMB shares. Who wants to guess how NetExec knows which shares are writable? Someone take a guess. Yeah?
Attempts to write to them?
Yeah. It tries to write to every single share. That sounds pretty easy to detect, right? Same IP address. It tries to write a random junk file to every single share, and if it writes the file, it deletes it. That's pretty easy to detect, so that's a detection you can write. And this is one of those things where I just happen to know how NetExec works because I've looked at the code, right? So if there are tools that you know are going to be used, which, by the way, NetExec is used extensively by the Southeast CCDC red teamers, or at least it was last year, learn how the tool works, learn how it works differently from legitimate stuff, and you can write detections based on that. Yep.
Does, like, when it tries to write, does it try to write, like, the same file, like it's netexec test.txt or something?
I believe it's randomly named. I don't remember, though, but you can check. Okay, initial access. Think like a red teamer for me. If you're a red teamer, you get access to a machine. Let's say it's like through a reverse shell or command injection. What are the first commands that you run? Anyone have any? Yeah? Nmap? That's a fair one. You're going to run nmap from their machine, though? Yeah. Probably not installed. Maybe ping, right? Ping could help, or netstat to look at the ports. Yeah? Who am I is a good one. Yeah. Who am I? Yeah. Who am I / priv? Who am I / groups? Those are big ones. These are things that just like are very common that red teamers do. Some companies live by this, that if someone runs who am I, they just assume that computer has been popped, right? Because most, like, IT is going to run it a bunch, but like finance probably won't, So if you see who am I, kind of suspicious. Same thing with cmd.exe. If you have this /c flag, it's running command from the terminal through cmd.exe. PowerShell has a ton of arguments that are suspicious. NOP, which is no profile. IES, that's invoke expression. IRM is invoke REST method, which is like the REST API, grabbing things from the internet. Execution policy bypass, encoded. This is for bypassing in base64 encoded stuff. It's almost like PowerShell was like built for attackers. It's so useful. W hidden, window hidden. Don't pop up a window when I open stuff. Ton of other commands. These are really suspicious. They're probably not going to happen like legitimately. So you detect this, you detect the parent process, and you can maybe see like, what attackers are doing. Questions? You?
Does Windows have its own version of aliases?
Yes, it does. It's called alias.
Crazy.
You can type in get alias, which has an alias called GAL. So if you type gal, it'll give you the alias for get alias.
Okay. And then follow up. These rules for detection, do they apply before, like when you type the command initially, or after the alias is applied? Because like for all of these, you're detecting like who am I? Could you just alias that to something else so you don't get detected?
That depends on the type of logging, and I'll talk about that later. Yes?
But you see like the same question.
Same question?
How would we get past that as a
I'll talk about it. What about you?
Are there any of these that would be good to just like all of these arguments and commands? Like, are there any that would be good to just like delete?
Block?
Yeah.
That's hard to say. I'm not gonna lie. I'm always wary of like permanently blocking things because it's the kind of thing that you're just not certain. right? Like all of these might be used by some random admin script running in the background. Who knows? It probably won't be, but it's the kind of thing that requires testing. My belief is that for CCDC, if you feel that something is very unlikely to be legitimately used, you should block it, but also alert whenever something's blocked. So that way, if you start losing points for a service, you should be like, oh my God, it's because I'm blocking this thing, and then you unblock it, or you add some like whitelists. Does that make sense? So I think you can probably block like most of these things, but like here's the thing, none of these are like PowerShell and CMD are malicious. The other ones are not. So you don't necessarily want to block them, just alert. Andre?
Just to clarify, when you say alert unblocking, do you mean like when you block a command or when someone tries to run a blocked command? When do you alert?
Well, they're the same thing, aren't they?
No, like when you block something, like the initial configuration, right?
Yeah.
Versus when someone tries to run that command that has been blocked.
Well, if they try to run a command that's been blocked, it will be blocked, which will cause an alert.
Okay, that answers the
Right.
question. Thanks.
All right, let's talk about Kerberos detections. This is like what really got me into Windows detections, and this is something that I feel is, I don't know, a lot of like pen testers do not know about this because they don't have to, but red teamers do. Now, in Kerberosing, right? Remember Kerberosing, I'm trying to request a service ticket for a service. Typically, what we do first, we can only Kerberos service accounts, right? So I query all the service accounts, meaning I query users that have the SPN set, the service principal name. A lot of the time, they will send an LDAP query, whatever tool it is, Impacket, NetExec, Rubius, will send an LDAP query that looks for this exact string, service principal name equals star. If I see that query, someone's probably trying to Kerberos, because who else is trying to query only the service accounts? Now, Impacket does this precise query by default, because it's faster, it's more efficient. Now, you can turn that off, and instead of querying just the SPNs, it'll query everything, and then on the attacker machine, it'll look for the SPNs. That's slower, but it's more OPSEC safe. It's harder to detect, right? But let's be honest, who actually cares about an OPSEC? Because when you're practicing, you're doing hack the box. It never matters, right? And for that reason, a lot of pen testers don't know about it, which is why I think it's going to be easy to detect. You also want to detect high numbers of STs. By default, all these tools will request a hash for every single service account. That's a bad idea. You should really be doing it targeted, only requesting one service account. But by default, it's going to request for everything. So if you see one user requesting a hash for every service account, that's really suspicious, right? Okay. Now there's another thing that's really interesting about Kerberosing and ASRep roasting, and that's that by default, all these tickets are encrypted with AES. They're encrypted securely, right? Now Windows has this negotiation thing where you can say, I don't like AES. Can you pretty please use something that's worse? And Windows will say, okay, we can use RC4. Now there's a lot of different encryption types. AES or E-type, encryption type 19 is AES, that's the default on most Windows systems. But they also support 23, right? Now because AES is really hard to crack and RC4 is pretty easy to crack, all the tools, Impacket, NetExec, and Rubius, by default will request E-type 23. So you know that attackers are going to be requesting E-type 23, but real people are going to be requesting E-type 19. So what do? I modify my, I forgot to, well, let's go back here, right? This rule. You see here I'm looking for a TGT being requested, and all I look for is a ticket being requested. How can I make this better? I also look for the encryption type, right? If the encryption type is 23, man, I am 100% certain that somebody is trying to do Kerberosing or ASRep roasting. That make sense? Okay. So yeah, look for weak encryption. These weak encryption types are disabled now on Windows 11 and Server 2025, but that's by default. You know, maybe you go into an environment where they just enable it again. You know, who knows? Okay. Now, there's another thing I didn't talk about yesterday called golden and silver ticket attacks. I have a golden ticket on my computer for this reason. And this is an attack where you forge a ticket. Instead of requesting one, you just collect all the information that's required to create a ticket, and you basically do exactly what the KDC would have done, and you make your own ticket. Now, by default on Windows, all these tickets have expiries of 10 hours. In packet, we'll set it to 10 years. Because, it's nicer for an attacker. So what do I do to detect things? I look for stuff that has an expiry of 10 years. Now, you can obviously, as an attacker, change this. But, a lot of them will not. Something else you can do is a lot of the time when a ticket is created, attackers will pass in the NT hash, whereas Kerberos will use the AES key, right? NT hash is easier to obtain, which is why attackers will usually use it, but it's not the default, so it's easier to detect. Yes?
So I'm curious, if you could do a gold and silver ticket attack
Yes.
once, why not just do it when 9 hours have elapsed instead of like changing it to 10 years or whatever? Just
You
so it's
can.
suspicious?
It's because you're saying, why do attackers set it to 10 years?
Yeah, so just
'Cause
like
they're
at 9
lazy.
hours, just make it a little bit.
Because they're lazy. That's it. When people wrote in packet, the tooling, they were like, what should I do? I guess I might as well make it 10,000 or whatever, 10 years, That's enough. And so that's what they do, Plus, sometimes if you have a ticket and like a password gets changed, you can't forge any new tickets, but your ticket still works. Unless you cycle the Kerberos TGT hash. That's the only way to make current golden and silver tickets no longer work. So that could be a reason, right? If you forge a ticket, it'll last for 10 years, even if they change the password of the user, right? Okay, so, that's another detection. Let's talk about credentials. Who remembers the ntds.dit file? Stores a ton of hashes, users, groups, that kind of thing. We can just look for file access to that. If someone copies it over, that's suspicious. You should note that there are a lot of ways to copy it other than just, copy, paste, or open, but we can look for that. You can also look for like a DCSync remotely. Who remembers what a DCSync is? It's when DCs sync with each other, right? Now, typically, a DC should only be syncing with another DC, right? Not to a user. You shouldn't be sending all your DC information to a user. So on the left, you can see here that there's a DC sync happening, and the subject username is user1. That's weird, right? On the right, you can see something legitimate where the subject username is DC0, and remember, machine accounts have a $sign at the end. Yes?
In your log, could you check for specifically users that end in a $sign?
Yes, you can do that. Now, you should note that users can also, by default, create machine accounts, which is why what you should do is you should check for your domain controllers. You should make sure that only your domain controllers are syncing. Other questions? But yeah, on the left, an attacker. On the right, a legitimate DC sync. Now you know how to detect this. For SAM and LSA secrets, these things are stored in these hives in the registry, SAM system security. If you enable registry access auditing, you can see anytime someone runs these commands. You can also enable command logging, and you can look for reg.exe being run, and you can look for keywords like SAM system security and that kind of thing. Okay. Here's an example. You can see registry machine security cache is being requested by the Ravy Davy Gravy user. I found that online because I didn't have time to find my own screenshot. But, and it's being requested by the Mimikatz process. You know what that is, right? But more suspicious stuff. Okay, lateral movement. Who remembers Evil WinRM? Evil WinRM, or WinRM rather, is something that actually works over HTTP, which means it has a user agent. And the user agent is Ruby WinRM client. That's suspicious. WinRM is a thing that is like a Windows thing. It's a Windows legitimate executable. And the only people using Evil WinRM are probably going to be attackers, right? So you can look for the user agent. You can see Ruby WinRM client. If that happens, someone's trying to log in as an attacker. And this is the kind of thing I would probably block, right? Like, I'll be real. Sometimes as a blue teamer, I use Evil WinRM, but I shouldn't. So I think this is something you should block.
What do you use Evil WinRM for?
To log in through with WinRM.
Oh, okay.
Yeah. It would make more sense to use like SSH.
Yeah.
Or that's really it, to be honest. Like maybe RDP, but you really shouldn't. Okay. There's a lot of different ways to get code execution. Who remembers I said that if you have local admin on a machine, you can execute commands? There's a lot of different methods. All of these are in-packet scripts. PSExec, WMIexec, SMBexec, ATexec, DCOMexec. All of them execute commands through different ways. Some of these are detected by Windows Defender, and some of them are not. All of them are totally different, but most of them, what they do is they create a service, which you should always detect on, because new services are not something that regularly happen, right? Now, something that's really, really interesting is that every single one of these will create a service or a named pipe with this format. Who knows what this format means? Or who doesn't know what this format means? Oh, wow. This is regex. Here's a snip from regex 101. This basically means 8 uppercase or lowercase letters and .exe. So everything that SMB exec, WMI exec, whatever, all of them will make executables like .exes or .bins with this name. So you know what I would do? I would just block it. Or at the very least alert, at level 15 because it's suspicious. And there's not that many executables that are 8 characters. I guess there might be some, but maybe you can whitelist things that are signed by Microsoft or something. Questions? There's a lot. Yeah?
Do people forge signatures?
You can have a self-signed signature, or if a company accidentally leaks its signing keys, which lots of companies have done, Microsoft has done it, NVIDIA's done it, then you can do that. Now, usually when things leak, they invalidate them, but it's possible. It's possible. Other questions? Yeah?
You mentioned before with if it's signed by Microsoft, it's probably okay or something. Did Microsoft leak
They do it frequently. They also have insider threats that will sell private keys.
Okay. So it's something that could very well happen.
I would say at Southeast CCDC, it's basically definitely not going to happen. Mm-hmm. At Nationals, it might, but the red teamers will claim that it won't. Some red teamers love to bring 0 days and love to bring some crazy, crazy tradecraft. Mm-hmm. Most of them won't. Well, some of them will do that. I don't know. I don't really fully know.
Oh, come on, Adam.
What?
Oh, come on.
What?
Some of the Nationals guys will absolutely do that. Don't kid yourself.
Well, yeah, some of them will. Some of them will not. I know one guy who red teamed for the first time last year, and all he used was NetExec, and he didn't know about any of the OPSEC stuff. And as a result, I hear that the blue team did very well. So, I don't know. But some of the red teamers have been doing it for 15 years, and they write their own tools all year, and it's crazy stuff. But, do whatever detections you can. Here's a great blog post about hunting for IMPacket. You should read it. All right, let's talk about delegation. Who knows what delegation is? I didn't expect anyone to raise their hand because I didn't talk about it. Delegation is something where you allow a service to access other services on behalf of a user. So for example, I can say, hey, SMB, you are allowed to access or impersonate any user because you need to be able to. Now, who remembers I said you can create machine accounts, right? By default, you can create 10 machine accounts on Windows. So let's say an attacker is trying to do delegation. A lot of the time to do delegation, you have to make a new machine account. Or maybe for a DCSync, someone's making a new machine account. They are probably, or they might, first query what their machine account quota is to see if they can make a new machine account. So you know what I should do? I should look for those queries. I can also just look for new machine accounts. That's not something that should happen often, new machine accounts being created. So you can say, there's a new machine account created by the red team user. Oh man, that red team user is probably suspicious. You can also limit these attacks by adding users to a protected users group. You're not allowed to delegate on behalf of a user in the protected users group, which is why you should add your admin user over to protected users. You can also prevent a lot of attacks by setting your machine account quota to 0. Questions? Yes?
When are new machine accounts usually made?
When there's new machines added to the domain.
Okay.
There's other reasons, but I don't know of any. Yes?
Could you just fill up your machine accounts with dummy machines and delete the ones and you add a new one so that attackers can't create a new machine account?
Are you saying for every single user, create 10 machine accounts on behalf of them? I guess that would technically work. But I think it'd be a lot easier to just set their quota to 0. Did you have a question?
Oh yeah. Is there a reason not to add a user to a protected users group?
Yes. So if you want to access a service, the only way you're going to be able to access that service is if the service is allowed to, if you delegate access to the service. Remember the example I gave yesterday about the file server? A file server can only access my files if they can basically impersonate me, right? So most users should not be in the protected users group because they need to be able to use services.
Okay.
The administrator user, any high privilege user, should never, ever be doing stuff like accessing a database or browsing your email because things will break, right? The admin user is only for admin stuff, setting up security things, looking at logs, right? But you want users to be as low privileged as possible, right? That make sense?
Yeah.
Okay. Other questions? All right. Let's talk about defense evasion. I think this is the last section. Now, a lot of the time, PowerShell, like Windows has this thing called AMSI, which is anti-malware scanning interface that they use for scanning things and looking for malware, right? And they also have Windows Defender that will try to look and find like suspicious things. Now, sometimes it'll detect things. So what attackers do is they obfuscate their PowerShell to make it less detectable. This is a website called amsi.fail, which will take what's called an AMSI bypass and obfuscate it automatically. Now, this currently is detectable by Windows Defender, but a few years ago it wasn't. Now, if I asked you, is this malicious? What would you say? Say it. Come on. Yes. How do you know? You don't know what it's doing, do you? Do you know what it's doing? But you know it's malicious, right? Right? How do you know?
Because no one does that.
Exactly. Nobody does this, right? So there's something really, really interesting with PowerShell obfuscation where, yeah, it's not detectable by the machine, but it's so easy for humans. But we as humans cannot really look at every single script. Here's another obfuscation thing. Here's another one. This is all white space. It's white space and tabs, and it basically acts as binary, I think. And it will, like, execute malicious code with just white space. That's kind of crazy, right? And, like, Defender might not know that that's malicious, but you probably do, right? Like, what are they trying to hide? So this is what I talked about PowerShell logging, right? This is something that you have to enable because it's not enabled by default. There's two types of PowerShell logging. One is called script block logging, which is something that I think is really, really cool, where it will take something like this and it'll evaluate it once and log the evaluation. And it'll evaluate it again and it'll log the evaluation, right? So here's an example from Cyberforce. That's a base64 encoded thing that an attacker ran, right? You don't necessarily know what it does. You can decode it yourself, but like you don't know what it does. But thanks to PowerShell script block logging, you can see the decoded version because PowerShell interpreted it and is showing you every single step of the way. So script block logging is really, really powerful. Now, the other thing that's really useful, and this is useful for aliases, is transcription, right? Transcription will show exactly the input and the output that was typed, which means while script block logging will evaluate aliases and things like that, transcription will not. It'll have exactly what the user is typing. So even if they have a comment, and the comment says, this is my reverse shell, even though the reverse shell isn't being executed, it's still there, and you can see it in the input, and you can see it in the output, right? So these are two things that you should enable, and you should look at extensively. I will say for Cyberforce had these automated checks that they would run every, like, hour or so, and nobody knew what they were doing, but I knew because I could just look at the logs, and I could see exactly what they were running through PowerShell. So this is one of those ways you can kind of game the system, and also something you can use to log, okay? Now, this is a blog post from Microsoft, but PowerShell, this what this post claims is that PowerShell is the best for security out of any other interpreter just because it has so many features, right? There's so many things you can do in PowerShell in terms of security that you can't do in other languages, which, by the way, if you are looking for things to add to our Trello board for CCDC, I really recommend looking into how to secure these different interpreters and languages. But PowerShell, luckily, is very easy to secure. By default, it has tons of logging, it has encrypted logging, it has application verification, it has sandboxing, tons of stuff. Something you have to make sure of is that attacker does not downgrade to PowerShell like version 3, because PowerShell version 3 doesn't support all the security stuff, but PowerShell version 7 does. So what you can do is just delete version 3, or you can alert when someone uses version 3. Make sense? Yes?
I had a question on the
Yep.
For the transcription, because it does like the actual like command.
Yeah.
Like for example, like ls, like isn't that like an alias for?
Get child item.
Yeah. So would it print like get child item? Would it log get child item?
It would transcription would show you ls, and then it would show the output.
Okay.
The script block logging would show ls, and then it would show get child item. That make sense? Yes.
Can you delete and alert? Because if you delete it, then you won't know if someone's trying to get in, which could be helpful information.
Like delete PowerShell version 3.
Yeah, but also get a notification if someone tries to run it and it fails. Like,
I guess you could, but I feel like an attacker would probably like see that PowerShell 3 doesn't exist,
oh, yeah.
like in the file system, and they wouldn't try it. But like maybe you could like figure out the path of PowerShell 3 or 4 or 5 and write that down. Like maybe, but I think it's unlikely to work.
Okay.
Yes?
So is, like with PowerShell being the most secure interpreter, does that mean like if we do have Python or whatever installed on our computers, if we wanted the most secure system, we would delete them, or is there a way to make sure that only we could access them, or like?
No, I don't know. You can log stuff. Now, Python does also have logging. I forget what it's called, but they have like a whole security system, and they also let you like prevent certain functions from being called. And that's actually thanks to inspiration from PowerShell, I think. But all of them have different logging things. It's just kind of, But yeah, you want to reduce attack surface. If you are on a production machine that users are not using, delete whatever doesn't need to be there. Yes?
Would it break anything internal to Windows if you like moved the command exe binary and the PowerShell binary?
I think so.
Okay.
I don't think you can delete those or move them.
Delete them, just like move them.
Yeah, because I assume that. Yeah, I think so.
Okay.
Maybe it wouldn't break some stuff if it was still in the path, but yes.
Have you ever actually tried deleting like PowerShell version 3? Would it like break the system or something like that? Would, like,
Probably
be
not.
An older dependency.
PowerShell 3, I don't even think it's installed by default, so I don't think it'd break anything. Okay. All right, so this is a really cool tool written by some people at Microsoft who work on PowerShell security called Revoke Obfuscation. If you're into like machine learning or you're into like programming languages, I think this is awesome. They did this thing where they parsed all the PowerShell code into what's called an abstract syntax tree, where they have all the different like elements of the script, which by the way, that's built into PowerShell. You can get the AST of the script. And they plugged in every single node in that tree into a machine learning algorithm that allowed them to, with like 99% certainty and almost no false positives, detect like weird stuff like this, right? And basically they trained it to be like a human, because a human sees this and they immediately know it's weird. But like, it's hard to do it as with a program, because what do? Do you look for character frequency? Well, these characters are different from these characters, are different from these characters. So it's hard to tell. But they wrote a machine learning algorithm. There's a really cool talk about it that I linked, or I have here, DEF CON 25. You should take a look if you're interested in AI, ML, security stuff. Questions? Okay. So one more thing that you can do. There's a tool called Yara, which uses signatures and executables. Am I taking too long, Alex?
No.
There's a thing called Yara that'll let you look for hashes, strings, that kind of stuff. And this is something that's really useful for looking for malware, right? A lot of the time they'll encrypt stuff so you can look at constants that are used in encryption algorithms. A lot of the time they'll have stuff that's, certain functions that we know are malicious, and you can use Yara to look for these attributes and scan things. Now this happens statically, right? So here's an example rule. I actually won't look at that, but I will show you this tweet which I think is really interesting. One of the most successful Yara rules that somebody wrote for malware is someone that just contains a bunch of profanity. Because apparently malware developers love cursing in their malware. And they love saying, I hate you, F you, whatever. So what people realize is, hey, let me just detect any profanity and any curse words. And this is surprisingly successful, right? You can also detect like Russian or Korean or something, and that's relatively successful as well. But, you can write a lot of interesting rules. Now, the unfortunate part about this is you have to do it like statically, right? And if something's encrypted, you're not going to find it. BlueSpawn, that thing I talked about earlier, does something really, really interesting where they will actively scan memory using Yara. So they'll look for things that are in memory, which, by the way, you cannot execute encrypted code. You have to execute unencrypted code, right? So BlueSpawn's a really cool tool. Unfortunately, CCDC red teamers wrote something called RedSpawn to basically make BlueSpawn useless. But if any of you are looking for like a cool senior project to do or something like that, or you just want to make a tool that UF can use to win and crush CCDC every year, you can try to make your own. I have a lot of ideas. I don't have any time, but you know, if you want to work on it, there's a lot of stuff you can do to emulate real EDRs. Now, there's a lot of malware techniques that I unfortunately don't really have time to talk about. I talked about bypassing AMSI, via patching memory, right? You want to look for when memory is being patched by like user processes, low-level processes, especially if it's the LSAS process, which stores credentials, especially if it's the AMSI process, which does malware scanning, right? You want to look for payload encryption. There's a technique called sleep obfuscation that will try to prevent memory scanning by sleeping for like 10 minutes, decrypting, executing stuff, and encrypting all in the span of like 10 seconds. So something scanning memory, if it's too slow, it might not catch the payload. Does that make sense to people? Did I explain that well enough? Yeah? And that's the kind of thing that's really hard to detect, but you can look for like functions that are known for encryption. You can look for functions that do something called process injection, where you inject your code into another process, right? There's all these things for import obfuscation that malware developers use, something called API hashing, where they'll hash their functions, and instead of calling a function directly, they'll call it by the hash name. There's something called a direct syscall, where you can, instead of calling a function in the kernel, you create the syscall yourself by recreating the assembly. There's also something called an indirect syscall, where instead of recreating the assembly yourself, you just call, it's basically like return-oriented programming, if any of you are in CTF, where you call the assembly from like one place, and then you call the assembly from another, you call the assembly from another to call a syscall. That probably was hard to understand. Don't worry about it. But basically, there's a lot of different malware techniques that are used for defense evasion. But luckily for us, anytime someone is trying to evade, that puts a spotlight on them, right? Anytime someone tries to evade, we know they have something to hide, so you should detect it. I have a talk down here about a lot of EDR evasion techniques if you want to learn more about that. It's a little bit more complicated, but like all of these things are suspicious, and all of these things are things that red teamers use, right, that you want to detect. Questions? No? Okay. Now let's talk about how to make your own detections really quickly. I really recommend making your own lab environment. Game of Active Directory is one that I really like because it has a ton of Windows machines, right? It also, as of like a week ago, includes Wazuh pre-built in. So you can just deploy it on Snap Labs or deploy it on Proxmox or wherever. And you can just attack stuff and log it. And you can see the logs, and you write rules for detecting your attacks, and then you make your attacks better. And then you say, I didn't log it now. Let me see if I can fix my logging. And you just go back and forth, and you become a great red teamer, you become a great blue teamer, and you like become this one all-powerful security person who knows everything, right? And home labs are a really fantastic way of doing this. If you want something a little bit smaller, a little bit less Windows, there's something called Detection Lab. It's like the same thing. It comes with a bunch of command and control frameworks. It comes with Atomic Red Team and that kind of stuff, and Elastic and other things like that. But, you know, make your home lab, just 2 machines, 3 machines, whatever you want. Set up Wazuh, Velociraptor, Sysmon, Elk, whatever you want, and experiment, right? This is how the blue team got its start. 3 years ago, we were totally clueless, and through our own experimentation, we got significantly better, and now we're teaching you. And, you know, that's good. You can learn. But if you really want to be great, and if you really want to make UF sit fantastic, and if you want to make us win, do your own experimentation, look for your own things, see how you can improve what we've done already, because I promise you can improve by a lot, right? So do that, and you will be great. And by the way, this is a talk based on a blog post I've been writing for the past 1.5 years that's still not done. I post things over here. Feel free to take a look. Any questions? No? Okay, I'll hand it off to Alex.